Yes, thanks for the intro. Okay, so here I composed a table that shows all the human activities we gathered spatial data on. So there are 14 different activities, and here I put the sources, and you can see this, it's gathered from a wide range of different sources, but Helcom map service, which you can find by just Googling Helcom map service, was a very good source because it contains in one file both the Finnish and Swedish data. And then we used some SEAmBOTH, and a lot of the layers was used by or created by analyzing aerial photographs. By the way, if somebody doesn't know what land claim means, it means, well, it basically means turning the sea into land. And yeah, next I'll talk a little about the aerial photographs which Metsähallitus did. So basically for the whole area, they looked at photographs and marked all the interesting sites. And as you can imagine, it took some time. And I've been told that for Finland, I don't know what the Swedish people are what their situation is, but for Finland, there will be a analysis like this done for the whole coast, and I think it should be ready pretty soon. And I'm going to presume that not everybody is very familiar with GIS or spatial data. So I wanted to dedicate one slide to basic stuff. GIS programs basically take in 4 types of data. They take in point data, line data, polygon data, and raster data. And some data can be in table format, and then you input it into GIS and it becomes points. So the table just contains coordinates. So points, of course, like I said, are just coordinates, and they don't have a size. They're basically infinitely small. They're just a position. And in this case, this what I used as an example here for points are dredging sites. And here we have a bridge that is as a line, and lines of course have length, but they don't have any width, so they're infinitely thin. And then we have polygons that are well, figures, and then for them you can calculate an area. And then we have rasters that are basically images with pixels. And the pixel size can vary. For SEAmBOTH, we used 20 times 20 meters. But anyway, rasters are the most commonly used data formats for almost any kind of analysis, because they can contain so much information. Each cell has a unique, or doesn't have to be unique, but each cell has a value that tells you something. So for example, this is a shipping density map, so each value tells you how many ships pass through that cell. After gathering all the human activity data, we created basically for every activity, you can say that it causes either loss and or disturbance. So loss is defined as causing permanent or long-lasting destruction of ecosystem components or nature. So, for example, if you place a structure in the water, obviously everything underneath the structure is going to be destroyed. Then there's disturbance that can cause damage or at least disadvantages, but it's typically only temporary. So, for example, when a ship passes through and it resuspends sediment. So here we have a dredging site, and dredging causes both loss and disturbance. So in this case, loss is pretty simple. You just say that where they dredged, the area was lost and nothing around it. Of course, how big the area lost is depends on how big the dredging site is, and some points, sadly, you can't say anything about the size, but some points had information about the size. So if it was a big dredging project, then it got a larger loss area. And then the disturbance is usually a little more complex. In the case of dredging, for example, the sedimentary suspension, the effects of it are highest in the middle, and then the effects start to dissipate towards the edge. And one way, if you have a point, like you can see here in the upper left corner, if you have a point, one way of giving it a estimate its area effect is to give it a buffer based on either attribute data or expert opinion. And here is a map of the physical disturbance from dredging. So the yellow parts are the areas with most disturbance. But when looking at this map, you of course have to remember that all of this didn't happen in one day, but it's most of the dredging sites we have been done within a 5 or 6 year period, and so a few of them were a little older. This long line here is, of course, dredging of a shipping lane, and then because most valuable areas are usually near the shore, or most life exists there, then we took this into account by weighing the layer with depth. Here's the shipping density. So this data is based on AIS, which is a tracking system that large ships have. And we also weight this one with depth. And by the way, I don't think I mentioned it, but basically everything we have, every human activity data set we have is gathered from open sources. And my last slide, here is a simple calculation of all the areas that have or are in some, at least a small degree, affected by human activities. So that is roughly 60%. But of course, keep in mind that a lot of this is from ship traffic and in deep areas. And actually, there are still some shoreline areas without any human activities. So that's comforting. Okay, thank you.